think about our hinge theorem for a minute. So with the hinge theorem, sometimes I have a hard time remembering which one is the converse and which one is the actual theorem. So the hinge theorem, we have two triangles, two different triangles, okay? And they have two sides in common. So, for example, that one right there is 3 inches. This one right here is 2 inches. And I'll come over here and we'll do this again. So I've got 2 inches here, 3 inches there. Okay, so this angle right here, it's 45 degrees. This angle right here, 75 degrees. So we've got triangle A, B, C, and I'll fill that triangle in now. And then we've got X, Y, Z. What do you think about BC and ZY? Yeah, I mean, when we look at those, ZY, the measure of ZY, is greater than the measure of BC. Is there any question about that? Does anybody look at that and say, no, that can't be right? Kind of has to be that way, doesn't it? Okay. Now, the proof for this one is a little bit of a thing, but let's just consider this for a minute. And what I'm going to do is I'm going to draw a radius of our circle, and I'll draw it over here at a right angle to B. So I'm going to draw, here's point B. And then I'm going to draw another radius over to point D, and I'm going to form an angle that is something less than a right angle. You with me? Okay. Now we could give these names. So I could call this one XY. I could call this one X subtract some amount. Okay. We could actually give them variable names. But the key here is when we start looking at the distances, if we use the distance formula to find AB and to find DB, what's the distance formula going to tell us? Which one's going to be longer? Yeah, it is. You know, of course, when we're using the distance formula, we're using that point both times, right? And then this point, its y coordinate is greater than this one's y coordinate, isn't it? But its x coordinate is smaller. Okay, but you can look at this and we know that's got to be greater. Now, what if I just give you two triangles like that? What then can you say about the angles? If you know that AB is longer than DB, what can you tell me about this angle right here? Right? And that's the converse of the theorem. Okay? So the hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then how do we say it? Then the third side of the first is longer than the third side of the second. That's hard to get everything out, but that's this case. I know this angle, the included angle here, is greater than the included angle here. These two sides are congruent. These two sides are congruent. Okay, we know YZ is longer, don't we? Okay, the converse would be we don't know what the angles are, but we do know that two sides are congruent, and the third side, YZ, is greater. Okay, and so this angle's got to be greater. Does that make sense? So you have the hinge theorem, and then you have the converse of the hinge theorem. When we prove the converse of the hinge theorem, we use an indirect proof, and we just assume it's smaller, and then we show that leads to a contradiction of the hinge theorem. So, you know, to prove the converse of the theorem, you use the actual theorem itself and show it leads to a contradiction that way. It's pretty straightforward. So let's just look at page 3 45 for a minute. Kind of get you used to this. Top of the page, example 2, two different triangles. Everyone see the two triangles? Do they have two sides congruent to each other? Yeah? And then the included angles. You see the included angles? 164, 161. So what do you know about JM in comparison to LM? Got it? Everybody understand that? Okay, JM's got to be longer. Now you have to have the two sides congruent, and you have to be talking about the included angle. Got that? Yeah? Y'all all awake, sort of? Okay. Let's go down to the bottom of the page, example 4 for a minute. And I want you guys to follow along with me for a minute here. Write a paragraph proof. Given angle XWY, can you guys find that in the graph or in the picture? Is congruent to angle XYW. See, they're marked in red, aren't they? Okay. And that WZ, can you find it? WZ is greater than YZ. Now, do we have two triangles here with two sides in common? We kind of got a picture. I might have to draw part of this picture for you. Let's see. I see a couple. I see this one is X, this is XZ. And then we have this one going up here to Y. This one coming up here to W. Oh, I did not draw that as an angle bisector very well. I have to try that again. So here we have two sides. These are congruent. Well, I don't know. Maybe are they congruent? What do you guys think? I'm doing all the work. You got to think. What we have is this angle and this angle are congruent, and that WZ is greater than YZ. This one is greater. It's longer than that one right there. We are to prove that angle WXZ, let's find that. We're supposed to prove that this angle right there is greater than this angle right here. What do you see? Can we use the hinge theorem?
We can use the converse.
Can we?
Eventually.
Eventually, yeah.
You just have to prove that XW and XY are congruent first.
Yeah. Are XW and XY congruent? You can't answer this. Next person. Are those two sides congruent, guys? How do you know?
Because in the book it is, and because of the converse of the angles theorem.
Isosceles triangle theorem. So, right here, just look at that part. You guys see that isosceles triangle?
Yeah.
Base angles are congruent, aren't they? Right? So the legs opposite those two base angles, they've got to be congruent. Okay, now think about this for a minute. Now, do we have the two triangles that share two sides in common? So here's one. You see the other one? So from here to here to here, there's one. Right? Okay. So we've got two sides. These two are congruent. Converse of the isosceles triangle theorem. And then they share this side one in common, don't they? So that's got to be the same. Okay. And then we're given that this side, WZ, is greater than YZ. What do you think?
Then you just use the converse of the hinge theorem.
Converse of the hinge theorem, then, isn't it? Okay. Turn the page over to 346. Actually, don't turn the page over. Just close your books for a minute. Okay. I'm going to have to force you into thinking for a minute. So, two groups of bikers leave the same camp heading in opposite directions. Okay, here's camp. Two groups leave the same camp heading in opposite directions, and I'm just going to draw. These guys are going that direction, these guys are going this direction, whatever. Agreed? We okay there? Okay. Each group travels 2 miles, then changes direction and travels another 1.2 miles. Are they both the same distance away from camp? Each group travels 2 miles, then changes direction, travels another 1.2 miles. Are they the same distance from camp?
It depends on which angle they turned at, which direction. So if they like went completely backwards.
So the guy's going this direction compared to this direction. It depends on. Can't they both just change directions and go 1.2 and be the same distance from camp? I mean, they've traveled 3.2 miles, haven't they?
If they both turned at the same angle, yeah,
So if they turn at different angles, so let's say this guy turns like this, and this guy turns like this. Are they the same distance away from camp? Can't see that very well, can you? Okay, so let's read on a little bit here. So, Group A starts due east. Okay, now we need to talk about on a map how this works. Okay, I think you guys are okay with north up, south down. You good with that? Mm-hmm. Okay. So now the question is, which way's west and which way's east?
west is on the left, east is on the right.
Logan did this. Good job, buddy. They're that direction. Okay, so just imagine you're looking at a map of the United States, right? Okay, where's California? On the left? Okay, so that's west. East over here, East Coast, right? New York, Washington, D.C. Got that? Okay, so Group A starts due east. So that's these guys. This is Group A. They go 2 miles, then they turn 45 degrees toward north. So what that means is they turn 45 degrees toward the north, which would be on their left. Okay, so this is the angle they're talking about right here. That's 45 degrees. Group B starts due west and then turns 30 degrees toward south. So these guys over here, they go 2 miles, then they turn 30 degrees toward the south. So this direction. So they turn to their left 30 degrees. Then they travel 1.2 miles and then we have to think about, okay, who's farther from home?
Guy on the last feed.
Who says A? If you won't talk, I'll make you read. Who says group A is further from home? Everyone looks around. Who says group B is further from home? Okay, but this angle is smaller. Shouldn't that length be smaller?
It's
What was that, Logan? So we're not talking about the angle in here. That's the amount they turned, right? But what's the angle inside the triangle?
it's maybe
Yeah, 150 degrees. What's the angle inside this triangle? 135, good. 135 degrees. So this is the hinge theorem. This is what the hinge theorem does. Okay? These lessons would take a lot longer, and then I wouldn't be able to assign them to you as fast if you talked more.
Then we're just wasting time because we still have to do the assignments regardless, so it's easier just.
No, if we get done and there's no time left, I'd be like, okay, we'll start working on it tomorrow. But you guys won't talk to me, so then we get done faster. Then I give you the assignment faster.
But then we can be done with these.
But then you could learn something by asking me a question.
yeah.
So, tomorrow, here's what's going to happen. You're all going to come to class, and you're going to have some kind of problem involving the hinge theorem or its converse, written on a piece of paper, and I'm going to call on you one by one, and you're going to hold up your paper and show me what it is. I don't care if it's the hinge theorem or the converse of the hinge theorem. It can't be two groups of hikers hike in opposite directions. Okay? Change it up a little bit. Look at something, I don't know, find something. Google it. I don't care. Find something. Write it on a piece of paper. Have it ready. And then I'm going to call on you, and you're going to have to use your words to explain it to me. Sound fun? That's the most I've got out of you guys. A low rumbling no. Good job, everyone.